Once again, welcome to Study by Yourself. My name is Sir Prince, and today I'm going to talk about the periodic table. Before I start, I'll encourage you to like this video and also subscribe if you've not done so. Hit the notification bell so that when I drop any interesting lesson, you'll be notified and you'll be knowledgeable about whatever I'm going to treat. So, you're welcome. Voila! This is the periodic table for just the first 20 elements. And before I start with the table itself, let me just talk about the things I've put around. By the time I'm done, nothing you are seeing will be foreign to you. You'll be so acquainted to them. Now, to draw the periodic table, you need 8 columns. So 1, 2, 3, 4, 5, 6, 7, 8. And you need 4 rows. 1, 2, 3, 4. This is the first 20 elements. Now, before I continue, you might be asking yourself, is it necessary to know about the periodic table? It is very necessary. By the time I'm done, you will know that, 1, getting the valency for element is that simple. Knowing whether it's going to form a cation or anion is that simple. And you know what a group is. You know what a period is. And you'll be able to interpret it when you are told that so and so elements are in a group or in a period. So first of all, let me start with this. Now you can see over here I've written loss of electrons plus, adding electrons minus. Now in mathematics, when you see plus, it means you are adding something. But over here, when you see plus, it means you are losing a number of electrons. So element which has lost, or atom which has lost electrons is known as a cation. And element which has gained electron is known as an anion. So when you come here, I've written 1, 2, or 3. Now this 1, 2, or 3 is trying to say that if an element has 1, 2, or 3 electrons on the outermost shell, it loses. So you can see cation. You can see cation. Okay, so any element you draw the electron configuration for, you write the electron configuration, and you realize that it has 1, 2, or 3 electrons on the outermost shell, it's going to lose. For example, when you look here, I wrote hydrogen. Hydrogen has 1 electron on the outermost shell, so it's going to lose. So it's going to form a cation. Also, I think this is lithium. Lithium has 3 electrons, 3 protons, 1 electron on the outermost shell, so 1. Then sodium. Sodium is 11, has 1 electron on the outermost shell, it's going to lose. The other elements as well, and I'll talk more about that when I get to the periodic table itself. Now looking at 5, 6, or 7, if you know the first 20 elements very well, you'll be able to know what I'm talking about. And if you don't know them, I'll advise that you know them. In my previous lesson, I spoke about the electron configuration, so I'll advise you to go and watch my first video on atoms, ions, and molecules. You understand electron configuration very well, and it's in the link description, so you can tap on it and you can just scroll down and then tap on it and then watch it. Now, when an element has 5, 6, or 7 electrons on the outermost shell, it gains a number of electrons to add up to 8. When an element has 5 electrons on the outermost shell, it will gain 3. It will need 3 to be 8. When it has 6, it will need 2 to be 8. When it has 7, it will need 1 to be 8. So they form an ion. Let me write it here. Now, to be able to differentiate between anion and cation, when you're writing a cation, you just see that the T has a plus. So as soon as you write cation, you just know that, oh, okay, it's positively charged, so it is losing electron. And writing the A for the anion, this A, the cross for the cross, what the bar used to cross the A, so that's the minus. So you see that, oh, okay, that one is negatively charged. Now let's come to the periodic table itself. Elements in the same column, we call the columns groups. So we have 8 groups. The elements in the same row, we call them period, like that. Now, hydrogen, lithium, sodium, potassium are all in group 1. Beryllium, magnesium, calcium are all in group 2. Hydrogen, lithium, sodium, potassium are all in group 1. Beryllium, magnesium, calcium are all in group 2. Boron, aluminium, group 3. Carbon, silicon, group 4. Nitrogen, phosphorus, 5 oxygen, sulfur 6, fluorine, chlorine 7, helium, neon, argon 8. Now all elements in group 1 are called alkali metals. Alkali metals, that's their name. All elements in group 2 are called alkaline earth metals. Elements in group 7 are called halogens. The elements in group 8 are called noble or inert gases. Now let me start from here. Noble or inert gases because they have their outermost shell fully filled. It's inert means that it cannot react with any other element. Now elements which form compounds either donate electrons or receive electrons. Inert gases or noble gases are fully filled, so they don't need to donate or release any electrons. Now elements in group 1, group 2, group 3 donate electrons. Since they give out electrons, they lose electrons, so they form cation, positively charged. So this was what I was talking about. I said group 1, group 2, group 3. Now group 5, group 6, group 7, they have 5 electrons. Group 5 has 5 electrons outermost shell. Group 6 same, group 7 same. So what do? They gain to add up to 8. So they form anions. They gain as they are receiving, they are negatively charged. So you might be wondering about group 4. Group 4, for example, with carbon, forms organic compounds, which I'm going to treat in upcoming lessons. So now I'm through with the groups. So now let's look at the period. Period 1, period 2, period 3, period 4. So I said the rows are called periods. Now elements in the same period have the same number of shells. They have the same number of shells, and that was what I was trying to indicate over here. Hydrogen will be 1 electron in the outermost shell, so it will have 1 shell. Helium will have 2 electrons, still 1 shell. Now according to the octet rule, the highest number of electrons a shell is supposed to have is 8. But looking at the first shell, now in my previous lesson I spoke about I explained 2n squared, saying that that's the formula to know the number of electrons a shell is supposed to have. The first shell is 1, so n equals 1. So 2 times 1 squared will give you 2. So that's why the first shell takes 2 electrons. Okay. So hydrogen, helium, the same period. Lithium to neon, the same period. Sodium to argon, the same period. Then potassium to calcium, the same period. So it means that helium and hydrogen will have the same number of shells. Same as lithium to neon and so on.